Okay, example 11. A pulley with a radius of 10 inches uses a belt to drive a pulley with a radius of 6 inches. Just realized my words are cut off there. There we go. Find the angle through which the smaller pulley turns as the 10-inch pulley makes one revolution. Okay, so the trick to this is when two pulleys are attached by a belt, this thing turns the same amount of distance as this thing turns. Okay, this one's bigger than that, so as far as the number of degrees being turned is going to be more on this, less on that. All right, so that's what when they talk about gear ratios, that's what they're talking about. All right, so the bigger the gear ratio, the more power you're getting, basically. So anyway, what we're doing here is we're turning this, and we're going to get this to turn more. Think about on a bicycle, the bike tire is bigger than the gear, right? So when you're spinning this here, the bike's turning, or actually the gear attached to it, usually smaller. So you're actually pushing this one, and you're making that one turn more. That's what's happening. So it's attached to the bigger tire. So anyway, that's what's going on. So what's happening here is it says the bigger pulley makes one revolution. So what I know then is theta 1 is going to be one revolution. Okay, and again, thinking back to what we've already seen from 5.1 day 1, there's a circle, right? If I'm going one revolution all the way around the circle, how far did I go? 360 degrees or 2 pi radians, take your pick. Oops, 360 degrees. Degrees or 2 pi radians. All right, take your pick. That's what one revolution is. So a revolution is not an angle measure. All right, so if they do say, and they do that quite often in these problems, one revolution, that is a fact, but 360 degrees is better. Or 2 pi radians is better. Which one do you think is easier to work with? Probably 2 pi radians, because that formula is a heck of a lot easier, right? So if I'm looking at S sub 1 is supposed to equal S sub 2, because again, the distance that belt moves is going to be the same, right? They're connected. So however far this pulley turns around, that's how far that belt's going to move. This belt's going to move the same distance, so S2 is going to be the same amount, just this is going to spin faster. Okay, it's going to go more turns, all right? But the distance that they turn is going to be the same altogether. And I know that S1 is simply dr, where d is theta sub 1 and r is 10 inches. And d2 is theta sub 2 and r2 is 6 inches. Okay, again, using that formula, again, because we're dealing with the radian measure, because again, that's what we're going to choose to use. Theta sub 1 is 2 pi radians. So r times d is equal to r times d for each pulley. And theta sub 1 is 2 pi, so if I put 2 pi right here, I'm going to get 2 pi times 10 is 20 pi. And theta sub 2 times 6 is what we get out of that. And finally, if I divide both sides by 6, because again it says find the angle is theta sub 2, right? So if I want to find theta sub 2, I simply divide by 6. I end up with theta sub 2 equaling 10 pi over 3 radians. My writing has gotten worse over the break here. 10 pi over 3 radians is equal to theta sub 2. All right. Now notice the directions in the problem. It says state your answer in radians and also in degrees. Okay. I personally, oh dang it. Tell you what. I personally like to use radians in these problems because the radian formula is so easy to use. All right. So for me personally, that's my favorite. So anytime I do these problems, I'm always in radians. If they ask me for the answer in degrees also, then I just go back to example, I think it was 8, right? Go from radians to degrees. All right. So if I have 10 pi over 3 radians, and I want to convert that to degrees, I know that 180 degrees is equal to pi radians. And I just take that fact that we've already learned, use that fact to convert. Radian cancels radian, pi cancels pi. 3 goes in 180 60 times. So 10 times 60 is 600 degrees. So go ahead and use the DR formula to get your radian measure, but then convert using the pi radians equals 180 degrees fact to get back to degrees. Give me both answers. And that's what I'm looking for.